Imagine standing in a damp, shadowy cave in northern Greece, a place where time has collapsed into silence. You shine your light on a skull, embedded in red-streaked limestone, and feel an eerie connection. Its hollow brow stares back at you, alien, ancient, and hauntingly familiar. This fossil shouldn't be here. According to everything we thought we knew, it doesn't belong in this time, or even this part of the world. Yet here it is. Not merely a relic, but a challenge to our assumptions, to our timelines, to the very tree of human evolution. This is the Petralona cranium, a 375,000-year-old enigma that refuses to fit any known species. It hints at forgotten migrations, hybrid bloodlines, and a Europe populated by beings stranger and more advanced than we've ever imagined. If true, it doesn't just rewrite textbooks. It rewrites us. It was 1960 when a local shepherd stumbled upon something strange deep within the cool belly of a limestone cave on Katsika Hill near Thessaloniki in northern Greece. He hadn't been searching for history-only shelter from the sun, but what he found would ignite one of the most enduring controversies in paleoanthropology. The cave, streaked with iron-red minerals and long known to locals as the Red Rock Cave, hid a secret locked inside its ancient stone walls, a fossilized skull, partially embedded, seemingly frozen mid-emergence from the past. Scientists were quick to arrive. What they uncovered wasn't just another fossil, it was a revelation. Dubbed the Petralona cranium, the skull would later be dated to around 375,000 years ago, placing it squarely in the Middle Pleistocene period when our ancestral landscape was a patchwork of evolving species and climatic upheavals. But it wasn't the age alone that made Petralona extraordinary. It was the morphologia mix of features that defied easy categorization. A heavy, jutting brow ridge, not merely prominent but hollowed out, with large frontal sinuses unlike those of Homo sapiens or even Neanderthals. The cranial vault was thick and rounded. But the face showed a strange combination of both archaic robustness and more modern symmetry. It was as if evolution had paused mid-stroke, leaving behind a face that didn't belong to any species we recognized. Was this an early Neanderthal? A late Homo erectus? Or something else, entirely an evolutionary offshoot that lived, adapted, and vanished before we ever knew it existed? When the Petralona skull first surfaced in the 1960s, its peculiar anatomy drew immediate attention. Yet its true age was vastly underestimated. Early assessments, based on superficial analysis and primitive dating methods, placed it at around 200,000 years old, already significant, but not earth-shattering. It wasn't until decades later, with the advent of advanced stratigraphic studies, electron spin resonance dating, and uranium series analysis, that the full scope of the fossil's antiquity came to light. The Petralona cranium, it turned out, belonged not to a relatively recent ancestor, but to a hominin who lived nearly 375,000 years ago. This revelation threw established human timelines into disarray. Such an ancient date placed Petralona squarely within marine isotope stage 11, a long interglacial epoch among the warmest in Earth's recent geological history. During this time, much of Europe, especially the southern Balkans, was lush and verdant, more akin to a prehistoric Eden than the ice-gripped landscapes we associate with the Pleistocene. Forests of oak, beech, and hornbeam covered the land. Grassy plains threaded between wooded hills. Wild horses galloped in herds, aurochs thundered through meadows, deer browsed the undergrowth, and rhinos wallowed in muddy riverbeds. Amid this rich mosaic, early human populations spread, mingled, and competed shaped not only by natural selection, but by changing ecologies and ancient crossroads of migration. Petralona belonged to a world far removed from our own, a world where the rules of survival were still being written, and where the line between species was anything but clear. Among all the features of the Petralona cranium, one stands out as particularly enigmatic: its hollow supraorbital ridge. This isn't just a pronounced brow, it's an architectural anomaly in the human fossil record. While modern Homo sapiens possess only a modest brow ridge, and Neanderthals have a thick, solid, protruding one, the Petralona specimen presents something else entirely. A prominent arch above the eyes that is internally hollow, filled with expansive frontal sinuses. Why would evolution craft such a structure? From a purely anatomical perspective, some paleoanthropologists suggest it was a form of cranial optimization, a way to reduce the weight of the skull while still maintaining structural robustness in the face. A lighter brow ridge could ease strain during locomotion or improve cranial balance without sacrificing strength, especially important for early humans engaging in physically demanding lifestyles. But the implications go deeper. Could this hollowed ridge have served a biological function beyond mechanics? One theory posits it was involved in thermoregulation, helping to manage internal cranial temperature in fluctuating climates. Others propose a behavioral dimension. Perhaps the expanded sinus cavity allowed for enhanced facial expressiveness, a critical advantage in social communication, even in the absence of language. There's also the tantalizing idea of sexual selection, that such a brow acted as a visible, dimorphic trait, favored in mate choice, like the antlers of a deer or the mane of a lion. Whatever the reason, no other hominin skull, not even the robust Neanderthals or archaic Homo sapiens, bear such a feature. It is not just a bone. It is a signature of difference, hinting at a lineage that played by its own evolutionary rules. In paleoanthropology, cranial capacity serves as one of the most telling clues about where a fossil fits along the human lineage. The Petralona skull, with a brain volume exceeding 1,200 cubic centimeters, sits comfortably within the range of early Neanderthals and even overlaps with the lower end of modern Homo sapiens. But brain size tells only part of the story. The shape, proportions, and facial features of the Petralona cranium introduce a deeper mystery. Unlike the classic Neanderthal, whose midface projects outward in a pronounced prognathism, the Petralona skull displays a flatter facial structure. Its orbits, the eye sockets, are smaller and more rounded, less exaggerated than those of other archaic Europeans. Yet it is far too robust, too archaic, to be classified as fully modern. The bones are thick, the mandible powerful, and the skull overall shows signs of a rugged, physically demanding lifestyle. Petralona walks a tight evolutionary rope, too developed in its cranial architecture to be Homo erectus, yet lacking definitive Neanderthal traits. It seems to hover in the liminal space between known categories. In this regard, it bears a striking resemblance to the Kabwe skull, also known as the Rhodesian man discovered in Zambia. Kabwe, too, defies clean classification, combining a large cranial volume with a patchwork of archaic and modern traits. Some researchers believe these fossils may represent an Afro-European corridor species, part of a transitional population that ranged across continents before the final split into Neanderthals and Homo sapiens. If so, Petralona may be more than an outlier. It could be a genetic bridge, a witness to evolutionary chapters that standard models have overlooked. This skull challenges the idea that human evolution moved in clear-cut steps. Instead, it suggests something more complex, a world of parallel experiments, evolutionary gray zones, and vanished lineages. To truly understand the importance of the Petralona cranium, we must consider not only its anatomy, but its geography. At the time this mysterious hominin walked the Earth roughly 375,000 years ago, the landscape of Europe looked very different. Sea levels were significantly lower than today, and the Aegean Basin, now a patchwork of islands, was a vast, exposed plain. It formed a natural land bridge, linking Asia Minor, what we now call Turkey, with southern Europe. This path became a crucial connection between continents. Petralona was positioned near the heart of this ancient highway. It stood not at the edge of civilization, but at a crossroads where cultures, species, and ideas could meet, mingle, and evolve. This location alone raises profound implications. Was the Petralona individual part of a northward migratory wave from Africa? Or did it represent a local population rooted in the region, evolving in isolation until more advanced hominins arrived? Some scholars suggest that Petralona's people may have been precursors to Neanderthals, an early branch that laid the groundwork for what would become Europe's dominant archaic humans. Others propose a more intricate story, that these early migrants were eventually absorbed by newer waves of hominins, possibly Homo sapiens, arriving from the east or south, bringing with them new tools, genes, and ideas. In this light, Petralona ceases to be a lonely fossil. It becomes a keystone, a critical piece in the puzzle of prehistoric migration. Its discovery hints that southeastern Europe, and especially Greece, was not a backwater of evolution, but a nexus where the tides of human ancestry met and transformed. In the bones of this ancient skull may lie echoes of the first great crossings, journeys not recorded in text, but in the shifting shape of our shared humanity. Just when the story of Petralona seemed complex enough, another discovery deep in the caves of southern Greece added a provocative twist. In the 1970s, and again with greater precision in the 2010s, researchers excavated a pair of ancient cranial fragments from the Apidima cave, nestled in the limestone cliffs of the Peloponnese. They would come to be known as Apidima I and Apidima II, two fossils separated not only by stone, but by species. Apidima II, dated to 170,000 years ago, displayed classic Neanderthal traits: elongated skull shape, strong occipital bun, and robust features aligned with Europe's well-established archaic lineage. But it was Apidima, one that stunned the scientific world. Dated to over 210,000 years ago, its morphology was unlike any European fossil from that era. It lacked Neanderthal features, and instead bore gracile, rounded contours more closely associated with early Homo sapiens. If the dating holds, and current methods suggest it does, this would make Apidima I the earliest known Homo sapiens fossil in Europe, predating the commonly accepted out-of-Africa migration by more than 150,000 years. Such a possibility shatters long-held models of a single late wave of modern human migration. Now picture it. In one part of Greece, you have the massive, archaic Petralona skull, with its hybrid traits and robust structure. In another, separated by time and terrain, you find Apidima I, light, refined, and strikingly modern. Two skulls, two species, both in Greece, both occupying overlapping landscapes, but possibly representing entirely different evolutionary paths. Were these populations aware of each other, separated only by epochs and geography? Or were they part of a broader, forgotten story of migrations, extinctions, and interbreeding that continues to haunt our genetic legacy? To view the Petralona cranium as merely a bone in stone is to miss the greater truth of its context. This was not an isolated fossil lost in geological time. It was discovered within a complex archaeological setting, one that reveals glimpses of life, survival, and possibly even culture. Excavations of the Petralona cave uncovered more than just ancient anatomy. Archaeologists found layers of charred wood, suggesting the controlled use of fire, a milestone in cognitive evolution. Scattered stone tools, some deliberately shaped and sharpened, indicate tool-making behavior, possibly even knowledge transmission across generations. Mixed among these were animal bones, some with cut marks, signs of butchering, hunting, or food processing. Taken together, these remnants point not to a chance encounter with shelter, but to repeated occupation. The cave may have served as a seasonal refuge, or even a semi-permanent dwelling during favorable periods. The stratified layers of habitation suggest a group that returned again and again, not wanderers, but people with memory, routines, and survival strategies tailored to a changing world. In this light, the Petralona individual becomes more than a skull. He or she was part of a community, however small or transient. They likely shared food, warmth, protection, and perhaps even early forms of communication or cooperation. Whether these people were our direct ancestors or simply evolutionary cousins, they were not primitive in the way we once imagined. They controlled fire. They shaped tools. They carved out life in a wild and unpredictable world, not merely enduring it, but adapting to it. That, in every meaningful way, is human. Once upon a time, human evolution was drawn as a simple, elegant tree, with Homo erectus branching neatly into Neanderthals on one side and Homo sapiens on the other. It was a tidy narrative, one species giving rise to the next in a progressive climb toward modern humanity. But as fossil discoveries multiply and genetic data pours in, that tree is beginning to look more like a braided river, tangled, overlapping, and impossibly complex. Lineages once thought to be separate now appear to have interbred, migrated, and merged in waves stretching over hundreds of thousands of years. Instead of neat branches, we see eddies and cross-currents, ghost populations that left little behind but their DNA in our blood. The Petralona skull may belong to one of these ghost lineages, a population that thrived in southeastern Europe, possibly for millennia, alongside both early Neanderthals and emerging Homo sapiens. It could represent a group that was absorbed into later populations, leaving behind no distinct descendants, but subtle anatomical echoes and perhaps genetic fragments still alive today. This idea is not speculative fantasy. Ancient DNA studies from sites like Cima de los Huesos in Spain, a cave that held the remains of individuals from 430,000 years ago, reveal genomes that show signs of both Neanderthal and even Denisovan-like ancestry. In other words, interbreeding was the norm, not the exception. Petralona, though genetically unsampled, may tell a similar story of a people who didn't vanish, but who melted into the evolutionary background, their legacy woven silently into the tapestry of humankind. What we once saw as extinction may, in truth, have been absorption, a quiet survival through interconnection. For decades, the dominant narrative in paleoanthropology centered around a single pivotal event, the so-called out-of-Africa migration, dated to around 60,000 years ago. According to this model, anatomically modern Homo sapiens left Africa in one great wave, eventually replacing all archaic populations across Europe and Asia. It was simple, clean, linear. But the fossils tell a messier truth. The presence of Apidima 1, a skull with unmistakably modern features, dated to over 210,000 years ago in southern Greece, disrupts this tidy framework. coupled with the Petralona cranium, dated to 375,000 years ago and bearing traits that suggest a long-standing local lineage, the evidence points to a far older and more complex human presence in Europe. These were not one-time migrations. They were waves, pulses of movement, often separated by tens of thousands of years, driven by climate shifts, ecological pressures, and perhaps even cognitive or cultural advancements. Some of these populations vanished, victims of extinction, isolation, or competition. Others adapted, persisted, or blended with newer arrivals. In this view, Greece and the Balkans were not evolutionary cul-de-sacs. They were crossroads, rich ecological zones where Africa, Asia, and Europe converged. A place of encounters, of experimentation, of reinvention. The Petralona and Apidima fossils now stand as sentinels guarding a deeper truth: that the story of human migration was never a single arrow pointing north. It was a network of journeys taken, lost, and occasionally rediscovered in the bones beneath our feet. What we are left with is not a migration event. It's a migration mosaic, intricate, overlapping, and still incomplete. Few fossils in Europe have stirred more classification controversy than the Petralona cranium. Since its discovery, paleoanthropologists have wrestled with a fundamental question: what exactly was it? The skull has been labeled Homo erectus, Homo heidelbergensis, and even archaic Homo sapiens, each term capturing a sliver of truth, yet failing to fully encompass its unique combination of traits. Some early researchers saw Petralona as a late-surviving Homo erectus, citing its thick cranial bones and robust facial architecture. But its cranial capacity, over 1,200 cubic centimeters, and derived features suggested something more evolved. Others folded it into the category of Homo heidelbergensis, a species thought to be a common ancestor of both Neanderthals and modern humans. But that label has since become problematic, increasingly seen by many as a taxonomic wastebasket, used for any hominin that doesn't fit neatly into existing species. A growing number of experts argue that Petralona may warrant its own classification not just as a species, but as a regional variant, a uniquely adapted population shaped by the climatic, ecological, and migratory dynamics of southeastern Europe. It may have evolved traits distinct from other European or African populations, reflecting local adaptation over hundreds of generations. Ultimately, what makes Petralona so scientifically valuable is not its label, but its position on the evolutionary spectrum. It is a transitional form, a bridge between the known and the unknown, a rare window into the morphing architecture of the human skull during one of evolution's most turbulent epochs. Taxonomies may shift, debates may rage, but Petralona stands as a cornerstone fossil, a bold reminder that evolution does not follow tidy categories, but flows through gray zones where definitions blur and new paths emerge. Of all the anatomical puzzles presented by the Petralona cranium, none has provoked more curiosity than its brow ridge, a formidable, hollow, and highly pneumatized structure that defies expectations. In most hominins, the supraorbital ridge is a solid bridge of bone. In Homo sapiens, it is modest and mostly cosmetic. In Neanderthals, it is pronounced but structurally dense. But Petralona's is unique. It contains internal air cavities, as revealed by modern CT imaging, running almost the full width of the ridge, a design more complex than once imagined. Why would evolution produce such a feature? One theory suggests that the expanded frontal sinuses functioned as biomechanical buttresses, reinforcing the facial skeleton against chewing forces while lightening the load of the skull. This design may have allowed the Petralona individual to maintain both cranial robustness and a large brain case without sacrificing efficiency or mobility. But the implications may go deeper still. Some researchers believe these sinuses played a role in thermoregulation, helping to manage temperature fluctuations in cold or humid Pleistocene climates. Others suggest they could have served a social purpose, a physical trait used in dominance display or sexual selection, signaling strength or maturity in a highly visual species. There's even speculation that such internal structures might have influenced the development of the frontal lobes, either accommodating their growth or coinciding with increased encephalization. In this sense, the brow ridge is not just about external appearance. It's a silent witness to internal innovation, a hidden trace of the evolutionary tinkering that shaped both mind and body. Petralona reminds us, evolution doesn't only sculpt the visible. It works in shadows, through cavities and curves, designing function beneath the surface of bone. When viewed in isolation, the Petralona and Apidima fossils are compelling. But taken together across time, geography, and anatomy, they demand a paradigm shift. No longer can we cling to the comforting illusion of a clean, upward march from primitive ape to modern man. Instead, these discoveries sketch a very different picture, a mosaic of humanity composed of regional variants, transient species, and evolutionary side paths, many of which left no name and no direct legacy. Only questions. Petralona may not be one of our ancestors. It may be an offshoot, a species that diverged early, adapted locally, and eventually disappeared, absorbed by stronger gene pools, wiped out by environmental change, or simply outcompeted. But its story matters. It is a testament to nature's restless creativity, to the idea that evolution is not a ladder, but a labyrinth, where progress is nonlinear and extinction is just as common as survival. The same goes for Apidima, potentially the oldest Homo sapiens fossil in Europe, more than 210,000 years old, and yet strangely alone in the archaeological record. Did its people thrive or vanish? Were they part of an early wave that failed, or the seed of a much deeper lineage than we've dared to admit? Together, these fossils turn the map of human prehistory into a landscape of experiments, some ephemeral, others foundational. They speak of crossroads, not cul-de-sacs, of fluid boundaries, not rigid borders between species. And in doing so, they reveal the greatest truth of all, that the story of our origins is not one of inevitability, but of chance, collision, and resilience. Messy, chaotic, beautiful, and far, far older than we once believed. At Prehistoric Shadows, we believe that these fossils are more than stone. They are echoes of lives lived, of choices made under mammoth skies and firelight. The Petralona Skull is not just an ancient puzzle, it's a mirror, reflecting our own questions about origin, identity, and meaning. It reminds us that we come from many places, not just one, that our species is not a straight line, but a braided stream of survival and adaptation. These are not just stories of ancient bones. They are stories of us, of who we were, who we are, and who we might yet become. And in the silent halls of forgotten caves, there are still whispers waiting to be heard. If this journey into the deep past stirred something within you, curiosity, wonder, or even a sense of belonging, then don't stop here. Subscribe to Prehistoric Shadows for more explorations into the strange, the lost, and the nearly human. Because history isn't finished. It's just buried, waiting for us to uncover it piece by ancient piece.